So welcome back everyone. Welcome to the session 12 of the Faculty Development Program on Sustainable Solution in Hybrid Vehicles, sponsored by AICTE and organized by the Department of Mechanical Engineering at Mangalore Institute of Technology and Mangalore Institute of Technology and Engineering at Mudbidri. Our speaker for session 12 is Mr. Durvankar Raut. For the benefit of the audience, I would like to give a brief about our resource person for this session. Mr. Durvankar Raut had earned his master's in solid mechanics and design from Indian Institute of Technology, Kanpur, and has been working with Device Electronics Private Limited for the past 4 years or so. His responsibilities at the organization include managerial, team building, and business related activities. He has built an EV integration team at Device and leads a team of multidisciplinary engineers working on interdisciplinary projects. Electric vehicle integration design and manufacturing is also dealt by Mr. Durvankar Raut at Device Electronics Private Limited, which involves the conversion of the internal combustion engine in light commercial vehicles to EV and also involves ICE 2W conversion to EV. He has also been involved in the design and manufacturing of EV battery packs of 300 volts HEV pack and so on. Mr. Rao is also bestowed a honor of Tech Acharya Award by Mahindra Technical Academy in the year 2020. With that, I extend my warm welcome to you, sir, and hand over the session to you.
Thank you, Dr. Vignesh. I hope I am audible.
Yes, sir, you are audible.
Okay, let me share my screen.
Sure, sir.
Is the screen visible?
Yes, sir, it is.
Okay, so we are talking about EV charging infrastructure today. Actually, charging infrastructure is a kind of word which includes all the things ranging from making sure that the batteries are charged at home, making sure that the charging is happening at the public charging infrastructure, making sure that the battery swapping infrastructure also comes under this umbrella, and maybe vehicle to grid, vehicle to vehicle. So all the V2X type of scenarios, they also get covered in this particular topic. So what I'll be doing is, although I have a lot of material to cover, we'll just stay aware of the time limits and try to finish cover all the things which are possible. If at all anything remains, and if you have any questions, you can anytime kind of intervene and ask that question, unmute yourself, ask that question, not a problem. So To give you a brief intro, we already have gone through multiple sessions wherein people have talked about lithium-ion battery a bit, and you must have till now understood that it is most expensive part of the vehicle, and that also poses challenge in uh, again uh, kind of making sure that the life of this battery, it does not get deteriorated because of the charging. So the charging has to happen within the safe region, uh, like we talked about yesterday during the BMS session. The safe operating area that needs to be uh, that needs to be taken care of. Safety challenges are there. Any energy on board comes with liability of safe operation. So what happens is, just like in case of IC engine vehicles, the petrol may catch fire, diesel may catch fire. Same way here, lithium-ion batteries, as they have like lot of energy stored in them, and uh, if at all anything goes bad, if there are chances of like uh, danger to life and danger to property. We have also talked about it yesterday and day before yesterday, I guess. Onboard energy is that needs to be highly optimized for the application, highly optimized in the sense that the uh, to balance between energy and power is very important. So if let's say I'm using the pack for a hybrid vehicle, in that case it is important that this pack needs to be of higher power rating than higher energy rating. If I'm using it for hybrid vehicle, let's say if hybrid vehicle like Maruti Suzuki SHUS hybrids, they have very small packs, and if you compare them with the battery packs which are used by pure electric vehicles, they are completely different. There the challenge is different. So in that case, the battery pack itself needs to be designed in such a way that it is best suitable for the given application, and it needs to be highly optimized. There are so many simulations people run. We already have in the earlier session we saw about thermal simulations. So all these things, they need to be taken care of, and at the end uh, we need to ensure that people don't feel that the range of the vehicle is very small. So the range anxiety that needs to be addressed, and that can be addressed by one good thing, that is quick charging. And now once we uh, once we are interested in these EV phenomena, you must have been like uh, browsing more on the internet about EVs. There you must be finding that EVs currently cannot charge at so fast rate. It takes like 8 hours, 10 hours, 20 hours, 30 hours to charge the vehicle. So if you read the specification sheet of any vehicle which is currently launched in India, maybe it is MG ZSEV, maybe it is Hyundai Kona, or the vehicles especially of the larger battery packs, or uh, electric Nexon. So all these vehicles, they take large amount of time for charging if you are charging them at home. So we'll be talking about such things a bit, and while dealing with the charging, we need to ensure that the batteries are charged through a controlled charging, and battery safety and life safety that needs to be addressed. So a controlled charging is very important. What are the challenges while dealing with lithium-ion batteries? Firstly, overheating of anode might happen, which might produce gases like oxygen or hydrogen, and during overcharging, and this cathode might uh, get so in this case it might give rise to fire and overheating of the whole battery pack if you don't take away that heat immediately. Otherwise it will go into thermal runaway. Then we need to address cycle life degradation as well. So the SEI formation, these dendrite formation, which you must have heard about. So this thing needs to be addressed. And here this can be done by checking that what is the operating temperature of the battery, what is the safe temperature of the battery, what is the safe charge and discharge rate of the battery, what are these limits for a particular DOD limit. Like if DOD is 10%, what is the limit for charging and discharging, and so on. So all these things, the charging, discharging, so here it depends on what is the temperature, what is the state of charge of the battery as well, and at the same time, how good is the thermal management of the battery pack. A fully charged battery has lower thermal runaway temperature and will vent uh, sooner than the one which is partially charged. So when I guess we have seen one video yesterday wherein this guy was showing this battery single cell which was punctured, and when it was punctured, one of the cell did not show any uh, any bad effects apart from little bit of overheating, while the other one directly exploded. And this happened because the fully charged battery has a lower thermal runaway temperature. And high C rates, high cell temperature, all these things, they degrade the battery life. So another thing which we need to notice here is the charging profile of the battery. Batteries, they need to be charged according to how much they can take the charge. Generally followed charging profile is like this, or generally observed charging profile is like this, which is wherein this blue colored line is showing us what is the charge current in amperes. The charge current is shown here in percentage, 0 to 100 percentage. The
Hello, Mr. Durvankur. I think we have lost audio. Please bear with us while we get the audio back. Hello. Participants, kindly bear with us. The speaker has lost internet connection and he will be joining with us shortly. Hello.
Okay, sir. Okay.
We have back our speaker. I request the participants to kindly pay attention.
My screen visible?
Uh, Not yet, sir. 1 minute. Let me check once again.
Yes, Dr. Vignesh, can you hear me?
Yeah, you're audible, sir. You're clearly audible, but on my screen, I'm not able to view your laptop screen, sir.
Okay. Now?
No, sir. Yeah. Now it's visible, sir. Yes. Please go
Okay.
ahead, sir.
So unfortunately, I'm not using laptop today. My wife has
Oh,
borrowed it. So uh, now we have no other choice but to use desktop. And its power backup, its battery has gone bad. It has got it is a leaked battery right now, so we are not using it. And so these are some of the challenges when it comes to batteries, that if at all they are not reliable, when something like this happens, your life changes. So you need to make sure that batteries are properly maintained. Now I need to also get my battery replaced, and the power backup will be back again. So we were
all right.
discussing about charging pattern of lithium ion batteries. This image is taken from internet, and what it shows is this blue color line here. This is a charge current in percentage, and this red color line here, dark red, this is charging voltage shown here, ranging from 0 to 4.5. This value here seems to be close to 4.2. So this is a most probably NMC or NCSL, okay, based on the voltages. Now, what other graph you see is this dotted color line, which is dotted line, which is showing charge capacity. So how the charging capacity is increasing from 0 to what is the value, 100%. Now, when you observe this line here, this is where all the slopes are changing. The slope of the charge capacity is changing, of the voltage is changing, of the this blue color charge current is changing, and this zone on the left hand side is known as constant current zone, because in this zone the current is constant. In the right side zone the voltage is constant. So when you are charging the batteries, in general what happens is your battery spec sheets, if you refer any spec sheets, the manufacturers give you what is the maximum current with which you can charge, okay, and what is the maximum voltage to which you can charge. And at maximum voltage, what is the definition of full charging? So all these things are generally given in manufacturer's catalog. Okay, so if you want, we can just browse over the internet and check these things. Let me check if we can find something here. So okay, so what do they give here is maximum constant charging current 72 amperes, CC to CV voltage of 3.65. Now this is a different chemistry cell, so the voltage which they are giving is 3.65, and in our case, in our graph, it is 4.2. Okay, so once the battery reaches 4.2, or this battery when it reaches 3.65, we need to change to constant voltage pattern. So the charger has to understand that the voltage is reached, and once the highest voltage like this one 3.65 is reached, you need to change the charging to constant voltage charging, and constant voltage charging means you are not allowed to cross this voltage value. We already have seen, I guess day before yesterday, when Chaitanya talked about what is the highest limit of the voltage, lowest limit of the voltage for lithium ion batteries. So this voltage, which is the charging voltage, is the highest limit of the batteries as well. So beyond which they are not allowed to operate. Otherwise, what happens is they go into overcharge state, which is dangerous for us. Dangerous for from the point of view, firstly, that they degrade faster. Batteries degrade faster, and it might lead to something called as anode plating. And once the anode is plated, then once the plating of the anode occurs, then the capacity reduces, first of all. Secondly, the internal resistance also increases, and that's what we call degradation of the battery. So we need to avoid overcharging of the battery at all cases. And that's why even if this 3.65 is the highest voltage, batteries are generally not charged up to this voltage, but little bit lesser voltage than that. What other things are given here is discharging cutoff voltage, and during charging, what is the charging cutoff voltage? 3.65. Okay, this is not a detailed spec sheet, so at what current we need to cut this charging off is not given. So what if you observe here, the capacity is continuously increasing at 3.65 or 4.2 volts here, right? So this line, which is dotted line, it seems as if it is a asymptotic line. So this will meet the 100% capacity at infinite time. But we cannot wait till infinite time, right? Somewhere here, let's say after maybe 1.75 hours, we need to cut off the charging, or 1.5 hours, we need to cut off the charging. Okay. Now, this is 1.5 hours for a battery which is being charged at 1C rating. Now, this battery is being charged at 1C rating. How do I understand that? Because if you look at this graph again, till the point that half hour is completed, the battery must be charged to 50%. Is it? Right? 50% and half hour. So this is a 1C rating of charging which is happening here. Now 1C rating charging, and still we are waiting till 1.5 hours to charge the battery. And at 1.5 hours, what we observe is battery is not fully charged, but charged up to 98 or 97.5 capacity, right? Anyways, what we do is we don't have to charge it till 100%. If you charge it till 100%, generally what happens is their capacity degrades. Degradation of the battery happens. So generally batteries are not charged to full 100%. That is something which we need to keep in mind. Same thing you need to also follow for your laptop and mobile batteries as well, because they are also lithium ion batteries. What are the charging modes? So this is how the charging has to happen. The current needs to be the charging. Initially it is operating in the constant current region, and later on it goes into constant voltage region. And in constant voltage region, you are cutting it off after you reach some minimum current level. So minimum current level can be like, in this case, 0.5% of the, or sorry, 5% of the current level. Once it reaches to 5% of the current charging current, then we'll say that it is fully charged. EV charging modes, there are multiple modes with EV charging happens. Now, earlier what we talked about is the battery. Now let's see how battery charging happens. For charging the battery, there is either a direct connection, mode 1 it is called. If you charge it with mode 1, what happens is there is non-dedicated power socket. And non-dedicated, like domestic power socket, what we see in our homes, 3-pin socket. It has simple cable just like any other instrument which you operate at home, TV and radio maybe, or a little bit bigger one, maybe fridge, AC, washing machine. So these simple cables, they don't have any special instrument which is attached on the cable. But if you have such setup at home, you might risk overheating. So some accident had happened recently at my home as well, and when I was charging an EV at home, so something happened. My wiring was not properly done, and it is a 10 years old house. So the wires, they also are not connected properly. The attachment of the wires, the junctions which were prepared, those were not connected properly. So they got overheated, and it started fire. Somehow, as soon as the fire started, I could notice that, and I switched off everything. And once I did the rewiring again, the problem of overheating was gone. But this problem, the risk of overheating is still there, and that's why this mode one is generally not allowed. The same case also happens with the batteries as well. When you are in mode one, there is no communication between charger and what is happening to the battery. So if you might remember older Nokia phones, 1110 or 1100, like that. So those batteries, we were observing that those batteries used to bulge very soon, right? If you don't kind of follow a pattern in charging. If you charge them till 100%, keep them overnight every day, after 5 6 months they will bulge. And this bulging is a phenomena which occurs when the batteries are overcharged in general. So if they are overcharged, if the bulging happens, that means it is now the battery has become useless, because bulged batteries, they are in the they kind of like are making producing gases inside, and once the gases are produced, they are not safe to use. Now, to avoid such risk, there is a mode 2. In mode 2, again, there is a direct connection between vehicle and grid. Vehicle and grid. Grid side means our domestic power supply. Like, you can think about it from the domestic power supply. And it also has non-dedicated power socket. Same thing like earlier. Same three pin socket. It might be 6 ampere plug, might be 15 ampere plug, based on what kind of EV you are charging. If you're charging an EV which is requiring 3 kilowatt of power, you need to charge it through 16 ampere plug, right? Uh, Non-dedicated power socket, cable with communicating charge monitoring device. So this cable will have something black in between, and this is something which will monitor the charge, what is the charging current. It also sometimes monitors what is the voltage at which the charging is happening. And once the voltage, highest voltage is reached, this charge monitoring device will cut off the charging. Okay. So this is a mode 2, which is safer type of kind of charging, you can say. And in this case, the BMS in the vehicle as well, it might sometimes communicate with this charge monitoring device too. So this communication, if it is happening, then BMS also might instruct this charge monitoring device to cut the power supply off. So similar on the similar lines, you can think about it from our new chargers which are coming for mobile phones, which are having very high charging rates, like 20-watt charger, 30-watt charger, 60-watt charger, like that. All the chargers, they are having this charge monitoring device on the which is there in the charging plug. And this plug itself is, so what they have done is they have eliminated this wire in between, and the plug itself is working as charge monitoring device. It is also communicating with what is happening to the battery on the mobile phone side. And once the status is known, then it goes into this high power mode. So initially when you charge, as soon as you connect, it is not in the high power mode, it is in the low power region, which is minimum. So some minimum power supply it gives. And as soon as it detects that the battery, what is the current battery state, what is the current SOC, and what is the current voltage, based on that, it changes the mode to high power mode. Okay. In case of mode 3, everything happens in the similar fashion, except what is happening here is dedicated power socket is there. So power socket which you have on the grid side, it has dedicated power socket. It will also need, this mode 3 will also need a dedicated cable. The cable, if you are seeing here, it has become thicker now. It will also need a dedicated cable, because you are supplying more power through this mode 3 of charging. And dedicated power socket, dedicated cable. So this is kind of like you are going into more safe mode of charging. So after mode 1, everything what is happening, mode 2, mode 3, mode 4, these are safer types of charging. In case of mode 4, there is indirect connection of the vehicle to the grid. So there is some fast charger which is installed here, and vehicle is not directly connected to the grid. So in case of mode 3, it is still AC charging. The AC power is coming from the grid to the vehicle. So there is a direct connection of the vehicle to the grid. And this AC grid might be three-phase AC as well in some types of chargers too. It might be single phase or three phase based on what type of charger we are using. Now, in case of mode 4, it is most of the times, or you can say 100% of the times, it is DC charging which happens, fast charging, indirect connection of the vehicle to the grid via external charger. The charger is also sitting outside. In case of mode 1, 2, 3, the charger is sitting inside the vehicle via external charger, direct current external charger incorporating charge monitoring and dedicated cable. So there is a DC current which is coming through this cable, and this is the fastest mode of charging because, and the name also suggests the same, fast charger. Effective charging capacity is that of the weakest link. For example, if the charger in the vehicle is of 7 kilowatt rating, and if power supply available from the grid is only 2 kilowatt, then charging will obviously happen at 2 kilowatt, right? But if the power available from the charging point is, let's say, 22 kilowatt, charger is also certified or kind of designed for 7 kilowatt. Cable is designed for 7 kilowatt. Then charging will happen at 7 kilowatt only. So this is something which we also need to keep in mind. And you can, again, whatever happening on the charging of the EV side, you can directly correlate it to what happens to your mobile phones as well. So if your mobile phone, if you can compare, let's say if somebody is using warp charging charger, and which is used for OnePlus mobiles, let's say. So if you use the same charger for your other phones like Nokia phones, maybe the charging will not happen at the same rate which this charger gives to the OnePlus mobile, right? Because in this case, the communication between charger and mobile phone is also important. If this in during this communication, if the charger detects that a different type of mobile phone is attached, and if that is unknown, then charging will happen at some constant current charging rate, which is something which is minimum, for which the charger is designed for. Same thing happens if you change the cable. If you change the cable, and if the cable is not certified for that charger, cable is not certified for that mobile phone, in that case as well, the charging happens at lesser rate. Now, if you change any of these three things, charging happens at least possible rate. Between the chargers, there are basically two types of chargers. What we see is something called as onboard charger, and another is off-board charger. In case of onboard charger, the conversion between AC to DC, it happens inside the vehicle. So if you look at this particular diagram, this blue colored box is electric vehicle. Onboard charger is sitting somewhere here. So high voltage DC power supply is given from onboard charger to the battery pack, and EVAC, which is EV supply equipment, which is AC here, there is a AC power exchange which is happening between EVAC and onboard charger, or what you can call it maybe EVAC and EV. So EVAC means electric vehicle supply equipment to electric vehicle. The power supply is AC power supply, and there is some communication pilot wire. If you see, this is for communication. Now, in case of off-board charging, wherein the charger, which is conversion of AC to DC, is happening outside the vehicle, and this charger is connected to the grid. The charger gives DC supply to the vehicle. Conversion of AC to DC happens outside the vehicle. So this EVAC is converting AC to DC as well. Okay. There are different charging standards which are currently popular in world, and if you see various regions and which type of charger do they use, what type of how do the charger look like, that is all given in this particular slide. So AC type, if you see in North America, they use something called a J1772 type 1 type type 1 charging socket. And same way, same thing is also used in Japan. In EU markets, generally, the type 2 connector is popular. Even same CCS type 2 is also popular in India as well. And in Chinese region, GBT is popular, while GBT also comes with some other vehicles as well, which are being sold in EU and Indian market as well. So India market has all these variations which are available right now. And Tesla has this standard connector, which they supply with the vehicle, and this is being supplied in all market except EU, because European region has mandated this type 2 connector. So once the government mandates a type 2 connector, they need to supply the type 2 connector with the vehicle. Different charging standards which we just saw here, same standards are here as well, again listed. On the DC side, so this is AC for slow charging, this is DC for fast charging. For fast charging, CCS1 looks like this, then this is a CHEDEMO standard, this is a CCS standard plug, this is GBT plug. Okay, CHEDEMO is abbreviation of charge demo, developed by Japanese automakers, different names given here, uses CAN protocol or vehicle side communication. So between charger and the vehicle, the communication which is happening is CAN communication. Okay, in case of uh, IEC 62196, which is IEC standard, which is same as that of this type 1 type 2, you can say. So 62196 again has been very popular in EU market, European markets. And then there is also SAE type charger as well, which is called CCS. So this is SAE type charger 1 and SAE type charger 2. So CCS and SAE and IEC 62196, these are similar currently. Chinese GBT is based on European standard, but it is with CAN. In case of this CCS charger, the communication is through grid side protocol, which is PLC, power line communication, it says. The long form for PLC is power line communication. So between the communication of the charger with the vehicle is with PLC, and the GBT has same communication with CAN. Tesla Motors, they use their own supercharger. So this is how CCS combo 2 charger looks like, charger plug and socket looks like. So this is a type 2 combo plug, and this is how its socket looks like. Okay, just give me a second. माझं सेशन चालू आहे, 1 वाजता फोन करतो. नाही ट्रेनिंग चालू. Am I still audible?
Yes, sir. Yes, sir.
So I just saw your message that the audio video feed is not coming. So I thought it is current message, although it says 25 minutes earlier. So the socket looks like this. Now in this socket, you can plug the AC plug as well, and you can also insert this DC plug as well. Okay. The socket on the vehicle will look like this, socket on the vehicle or on the charger, if the charger also has the similar protocol. And if the charger is directly giving the wire out, then on the plug you will see, on the socket on the vehicle side you will see similar to this kind of plug. Okay, And when it comes, if the vehicle is being charged with AC power supply, you'll use this type of plug. If it is charged with DC power supply, you need to use this type of plug. The different pins and how do they, what are their functions, these are all given here. You can find this information on the internet as well. Okay, I have also taken from the same source. uh, so different pins have different functions, obviously. Okay. Charging standards in India, AIS 138, it gives part 1 talks about part 1 and part 2 talks about AC and DC charging, EV conductive AC charging system. This is based on, again, similar IEC standards 61851. AC slow charging, which is defined in the same standard. Part 1, part 2 both talk about, so I guess part 1 talks about AC charging and part 2 talks about fast charging, which is DC charging, but I need to check that. AC slow charging 230 volts, which is standard voltage in India, single phase 15 ampere outlet with connector of this standard and related safety interlocks. So if you just make a simple calculation of 230 volt 15 ampere means how much power can this AC power supply give us. 213 into 15, which is close to, I guess, 3.4 how much, 3.5 kilowatt, right? So maximum up to 3.5 kilowatt charging can happen with AC supply. Now if your charger is also of 3.5 kilowatt rating and battery pack is of, let's say, 35 kilowatt hour capacity, then it will take 10 hours for that battery pack to get charged, right? And if the battery pack is even higher than that, then it will take multiple amount of so many multiples of hours of charging time. AC fast charging, it will be through 3-phase supply and 63 ampere outlet connector, again 62196 connector, related safety interlocks. So here this talks about how 3-phase charging will happen, and this talks about how single phase charging will happen. Single phase charging, I guess this is a standard industrial connector. AIS 049. Okay, some other standards which are talking about EV charging. Let's see what a charging standard generally specifies. So charging standard specifies what kind of plugs need to be there on the charger side, what kind of socket needs to be there on the charger and on the vehicle side. Vehicle connectors, vehicle inlets, conductive charging of electrical vehicles with related operating voltage and currents not exceeding. So the voltage should not exceed 690 volts AC, which is again not possible in India if you're directly getting supply as a 3-phase supply and domestic 3-phase supply. So it is generally 420 volts, right? 50 hertz to 60 hertz, again considering what are the frequencies which are generally followed worldwide. 250 amperes maximum, 1500 volt DC, 400 amperes of current at this 1500 volt DC, but 1500
Hello? I think our author is back. Okay. We have just lost him. He's facing some power issues. Kindly bear with us. He'll be back. Mr. Swarup, we have just lost our author's connection. We are trying to get it back. He seems to be facing some power issues. Once that is sorted out, he'll be back. Then I'll post your questions to him. Sir.
Okay, sir.
Thank you for your patience. An unexpected delay has been caused due to power outage at the end of at the speaker's end. So we'll not be able to continue further with this session. We have another session lined up at 2 o'clock today. So kindly do join in at 2 o'clock for a talk on EV analysis and crash test analysis by Mr. Ashutosh Singh. We'll have to unfortunately terminate this particular session right over here. I'll be posting the attendance link through the chat window. Students are once again reminded not to enter any data through the link that will be given right now. It's meant only for the FDP participants. So please provide your feedback as well as attendance through the Google form link given in the chat window. And kindly do join us at 2 p.m. today for session 13. Thank you. I request the students to disconnect the line. Faculty, kindly access the attendance link posted on the chat window, and you may also disconnect your line. Using the same Google Meet link, kindly join us at